example is funding. Now, for athletes, this is really important because they're representing our country and probably it's their career if they're at this elite level, because I did only test the elite athletes in the national team. And so only 10.3% of the almost $800 million budget went directly to these athletes during the 2009 and 2012 quad, so that was leading up to the London Olympics. So if these athletes are not getting funding through the US Olympic Committee, then where are they getting funding from? Well, they have to subsidize all of their tournaments, all of their training, their travel. They go to 6 countries a year, and they go to 4 domestic tournaments, and so they're always traveling, so it's very hard to even have a normal job. So I found that funding is probably a very big stressor for them. They have to perform in order to be able to pay and fund for their, and get grants for fencing. Now my methods, I had to get approval through the Institutional Review Board. So IRB, they also had me get approval through US Fencing. And after that, it was participant recruitment. So how did I choose the participants and how did I recruit them? What I did was I went to the online, they have the points list, and I chose my lens to be on nationally ranked fencers. And so I went through the points list and I reached out to fencers because I am in the fencing community. It really wasn't a challenge. After I sent them an email, and if they wanted to participate, then they got a consent form. And yeah, then they became participants. That was super awesome. I also wanted to make sure that they were going to be at all 3 tournaments. That did not end up happening, but you know, for the most part, I was trying to get very consistently athletes who are competing at all the tournaments. And I chose to test salivary cortisol. So instead of serum, so salivary cortisol takes 20 minutes to show up. Cortisol takes 20 minutes to show up in the saliva. So when I was going through and collecting these samples, I had to time it so that it was 13 to 15 minutes after they fenced, and so that would measure their cortisol level while they were in that stressful situation or that direct elimination bout. And the way that I collected it was using salivettes. That is this right here. This is really the cryotube, and the salivette is this piece of cotton. And they just have to like chew on it or suck on it for about 30 seconds to get a certain amount of saliva. And that has to be put directly on ice, and then it has to be frozen within 48 hours. So I overnight shipped them to the lab and was able to freeze them. And the moments I chose for collecting saliva was every participant, I took a sample in the very beginning of the day before their tournament, and then 1 sample after they fenced pools. And the pools is important because that seeds them for the rest of the bracket, the rest of the tournament. And then I took 1 sample after every direct elimination bout. So the only sample that is after defeat would be their very last sample. Other than that, all the other samples are after a victory. And the way that I analyzed it was through ELISA, or enzyme-linked immunoabsorbent assay. And so that's this 96 well plate. And then that goes through a plate reader at 450 nanometers absorbance. And then I had to do calculations to find the adjusted optical density. And we did some statistical analysis and graphs. So I'll kind of touch on those in a second. So for my calculations, once the adjusted optical density was calculated, the data set had to be normalized. And so we normalized the data set so that it accounts for all individual differences. So that if there really is an optimal amount of cortisol for performance, then it's going to be an optimal amount for all of the athletes in the same range. The first way that I chose to graph the cortisol was difference in score versus change in cortisol. I know this is a lot to look at, so I'll try to walk you through it. First, we have the x-axis, that is difference in score. So the bouts go to 15 touches. And so if it is on the positive side, then that means that the participant was winning by that margin. And if it's on the negative side, it means the participant was losing by that margin. And the y-axis is change in cortisol measured in micrograms per deciliter. And so if it's in the positive, that means that their cortisol levels increased. And if it's in the negative, it means that their cortisol levels decreased. And for the legend, so for example, we have the participant number followed by the tournament. So participant 3, that's their number, and that was the January tournament. They were also in the October tournament as well as the December tournament. So that is the same fencer through the 3 different tournaments. And we didn't find too strong of a trend here, but go to the next graph. And here it's difference in rank versus change in cortisol. So we thought that perhaps if there was a big margin in difference in rank, that either if you were the top dog, you would feel like the pressure to really beat and come out with a victory against somebody who's lower ranked than you. So we have difference of rank on the x-axis and change in cortisol on the y-axis. And again, negative numbers mean either a decrease in cortisol or the participant was that many ranks below their opponent. And the third way is change in cortisol versus a victory or a defeat. So victory and defeat is on the y-axis. The victories are 0 and the defeats are 1. And we, again, didn't really find a trend. So what I decided to do was do additional graphs. And so I did it more on an individual level for the participants. And so for participant 4, they were at all 3 tournaments. So the blue bar goes with the October tournament, the orange bar is with December, and the gray bar is January tournament. So there were 3 tournaments. And I put their cortisol level during that bout inside of the bar. And so you can see from round 6 to round 7, there was a peak in this participant during the December tournament. So so this was their losing bout, so they did have a peak in cortisol. And I provided additional information, so I kind of put all 3 graphs together for the participants, more on an individual level. So round 8, we see that they were 37 for December. We see that they were 3 ranks higher than their opponent, but they lost by 7 touches. And so then we see for round 7 that if we're looking at the October tournament, so their cortisol level was at 0.302 in round 7. They were 40 points ahead of their participant in ranking, and they lost by 6 touches. And we see a peak in that tournament as well. So it goes from 0.29 to 0.30. So it's a slight peak, but still there. And I did this for all of the participants, mostly for the ones who were either who were at 2 of the tournaments and were at 3 of the tournaments. Participant 6, we see the same thing. We see that they peak at their last bout. It goes from 0.307 to 0.315, and then on round 8, they were 63 ranks above their opponent, and they lost by 6 touches. Something that's interesting on this graph is round 4 for the December tournament. That's quite a big peak, and so they won that bout. And so round 4 for December, they were 29 points above 29 ranks above their opponent, and they won by 8 touches. So it could be that they knew how to use that extra cortisol levels or stress in order to come out with a win. And I did the same thing with participant 16, and we see that she had a steady increase in cortisol levels from one DE to the next.